Hello guys, welcome to my channel. This is Java Data Structures and Algorithm course, and today's tutorial is about implementation of a sorted set that is based on an array. So we will maintain the order of elements in the ascending order. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Introduction of set data structure. Set is a linear data structure. Set stores unique elements of the same data type. Set can be implemented using an array or a linked list. Array can be fixed array size, or we can use a dynamic array that will grow its size or resize it itself whenever it requires more memory. Sorted set maintains ascending order of its elements. All the elements must be unique and they are in ascending order. Set contains special functions. For example, union, intersection, difference of sets, complement of a set, disjoint sets, and proper subsets. These functions are not available in other data structures. So these are special for the sets. Time complexity, insertion. Because set can be implemented using different data structures behind the scenes. So if we implement array based data structure, so it will have a best case O1, and if O1 happens if the set is empty. Then we have average and worst case scenario. Linked list based set has O1 when the set is empty, On when the insertion is carried out at the end of the set. So we have to navigate to the end of the set and insert the new element. We can achieve O1 runtime for insertion at the end if we add another instance field to keep track of the tail node within the set. So we can use that tail node and insert instantly at the end of the set, and we can achieve O1 runtime. It all depends on the design pattern that you will adopt to implement the set. In the case of insertion into a sorted set, the runtime complexity will be O(n) square, because you always have to navigate in the array, locate a location, and then have to shift the elements towards right to make a hole within the array and then insert the new element there. So O(n) is the complexity for searching for the correct location, and O(n) again we have to shift the elements, so it will become O(n) square. Runtime for the average and the worst case of insertion within the array, sorted array. In case of sorted linked set, this insertion will be carried out within O(n) time, where n is the number of elements. We have to search to locate a correct location to insert the new element. Same way, if we are implementing set using an array, the deletion will be O1 in case the set has single element and removed from the front of the set. Otherwise, if this is not the case, the complexity will be On for average and worst case scenarios, because we have to shift the elements to fill the hole created by removing the elements from the underlying array. In the same case for linked list. If we implement set using a linked list, the runtime is On if the element is removed from the front of the set. In case of average and worst cases, they will happen when we have to search for the element. If element exists somewhere between the linked list, we have to iterate to locate and then remove the element, and its complexity is On. In case of using the additional field tail in the linked list, we can achieve O1 for the removal of an element from the end of the set, because in that case we do not have to iterate or traverse the linked list, that is storing the elements behind the scene, and we can directly access the last node and remove it. Search is sequential. are linear for unsorted sets, no matter whether we use array-based implementation or a linked list-based implementation. So runtime is O1 if the first element is the search element or the search key. Otherwise, we have to use ON complexity in case of average and worst case scenarios. In sorted array-based set implementation, if we are implementing array sorted set using an array, we can utilize binary search, which is way faster than ON, and its complexity is O log n. But this binary search is very hard to implement in case of linked list based implementation. So it is only useful if we are utilizing array for the sorted set. Accessing the size of the set is O1 always, because we can directly return the number of elements stored within the set. And print function O1 if there is one element, ON otherwise. In best and worst cases, N is the number of elements stored within the set. So print has linear runtime, that is ON. Thank you guys. That is all. Let's start the code. And again, if you have not already subscribed the channel, please subscribe. Thank you. Hello guys. I have created the application in NetBeans and we are going to implement sorted set that is based on an array. So there will be two classes, one for the testing of the application and other one is to implement the set data structure, and this data structure will maintain an array behind the scene and keep the order of the elements in ascending order. So let's begin with the coding. So first of all, we need array. Let's say we set a initial capacity, and this array will be dynamically allocated and will grow if needed. So private final int capacity, let's say 100. So array private int, let's say array, or let's say data. Now keep track of number of elements. So we need a variable to keep track of current number of elements. So let's say private int count. Okay, so first thing, within the default constructor, we will set up the memory for the array. This data is equal to new int and capacity. And we also initialize count to 0. In Java, basic types are initialized automatically, but it is a good habit to initialize the variable. So I'm going to implement two types of functions. Basic functions, basic, let's say data structure functions, and next set functions. Set functions are exclusive for this data structure because they are not normally implemented for any other data structure. So basic function, let's say public boolean add int value. So our first function will be add a new element within the into the set and maintain order of elements. So being a set, add function need to take care of following things. Number one, no duplicate. So unique feature, unique elements. And number two, maintain the order. Okay, value to add and return true if added, otherwise return false. Okay, we will implement this function shortly. Let's create the prototypes. Boolean remove int value. So when we remove an element from the set or sorted set, we do not care about or consider order because they are already ordered. And if you remove some element, other elements will be in the order already. So we just remove an element from the sorted set. Value to remove. If removed, return true, otherwise false. Now public boolean, let's say public int find, int value. Instead of boolean, we return the index of the element if found. Find the index of an element within the sorted set. Value to find, return index of element or -1 if not found. Okay, next public boolean is empty. So this is simple function. We return count is equal to 0. Check that if the sorted set is empty. True if empty, false otherwise. Okay, next we need print function. Public void print the sorted set. So check if this dot is empty, print a message, sorted set is empty, and return from here. Return is the better statement instead of using if else. Okay, if we have data, so we print it as out %d and data 0. Now the rest of the elements. For int I1, I is less than. So we loop to print the rest of the functions, rest of the elements. I is less than count, I plus plus, and data I, and at the end we close the square bracket. So this is how we will print the set. Okay, now the grow function. Let's say make it private void grow. Function to increase the underlying array size. So what we will do, declare new array to hold current data. Int temp is equal to new int and count. Copy. I am writing this routine by our own code. There is a Java class java.util.arrays that has lot of functions to manipulate arrays like copy, resize, and other things. So I'm not going to use that class because the main purpose of this tutorial is to learn programming. So let's do it by our own coding. Int I 0, I is less than count, I plus plus. Okay, now temp I is equal to data I. We can do an other thing also. We can simply multiply by 2 and this new array will become the larger array than the required data, and just copy all the current elements into temp array and then assign it. assign to data. Data is equal to temp. That's it. We do not need to do anything else. And another option is we should copy temp array into data after resizing. This step will cost n time. So we can save this to increase the performance of our code. Allocating double memory here and then copying into temp array and then assigning the data, that is enough for the grow function, and we can skip this step. Normally people used to write this step, especially the people coming from C or C++ programming. They used to copy back, but we can achieve this step by we can remove this step to increase the performance of the code. Okay, now let's do the rest of the coding. Okay, now the find function. Int index is equal to -1 for we don't need this. Int I is equal to 0, I is less than count, and I plus plus. Iterate entire array if data I is equal to value. So we return the index. Otherwise, if we reach here, return -1 to indicate not found. Okay, I made the font too big. After a couple of lines, it goes down. Okay, now the remove function. Okay, for remove, find the index. So we already have a function that finds the index of the element. So we find it through int idx is equal to find and value. If idx is greater than equal to 0, if element exists, if idx is greater than equal to 0, otherwise we return false because the element does not exist. Okay, to remove the element from the array, we shift one step left, shift left all elements to remove value. Okay, so how we do that? We loop for int I is equal to idx. Start from the idx, the index of the value that we found through this function, and I is less than count -1, and iterate up to n-1 values, and I plus plus, and we simply shift data I is equal to data I plus 1. Make sure you use this condition n-1. Otherwise, if the array or set is full and you are looping through this, it can cause an error and throw an exception, array out of bound exception. Okay, once it is done, shifting is done, we reduce the count and we return true. That's it. This is over. Remove function from the sorted array. Array is equal to 0 because if it is -1, the value does not exist within this sorted set. Okay, the next over add function. We need to take care of a lot of things. First, array capacity. So if this dot let's say count is equal to this dot data dot length. So if the underlying array is full, so we will do grow the array. So but just call the function. Next, we need to know if value already exists. So how we do that? Int idx is equal to find. We call the find function. Okay, if idx is equal to -1, this means value is not in the sorted set. Otherwise, we return false. Simply, we do nothing. So if it is not in the sorted set, we will add to the correct location. So to find the location, there are two strategies. Number one, people do search the location, then shift the elements, and then assign the value. This will cost you 2n performance time complexity cost. And if we do in single loop and we shift the elements until we found the location, this will save us time and improves the performance of the code. Let's see how we can achieve it. So for idx is equal to count -1, we start searching from n-1 element from the end of the underlying array, and then we check the condition idx is greater than 0 and data idx is greater than value. As long as the value is greater from the current array index, keep on iterating, and idx minus minus, we are going backward from end of the array to the start of the array. And what we do, we keep shifting the elements towards right, so that there will be a room or there will be a hole in the array to assign the new value. So how we do that? Data idx plus 1 is equal to data idx. So the current index will be shifted one position towards right. That is why we are using this condition. Okay, we are basically starting with the element index that is n-1. Okay, next we will assign the value. So data index plus 1 is equal to new value and increase the count. So we assign this loop will take the idx to a position that is one position left to the actual position we need to store. For example, let's say we have elements 1, 3, 7, let's say 10 and 11, and we start searching and insert 8. So this function will start with this, shift it to this position, and then move this element to 11th position and reach here 7. So reach at 7. So after reaching at 7, the condition becomes false. The value at ith index is smaller than the 8. So the index becomes 2, and we supposed to assign it here. So that is why we use idx plus 1. Okay, that is how we implement our function. So we maintain, first we check the capacity and increase the capacity if needed. Then we checked if the element already exists. If it does exist, we return false. And if it does not exist, we locate the actual position to maintain the ascending order of the elements and assign the value and increase the count and return true. That is our faster function as compared to running two loops. First loop to locate the position and the second loop to shift the elements. Instead of using two loops, use single loop to shift the elements right until you reach an element that is smaller than the new value, and then assign the value to the next index. This is our set data structure that will maintain its order at the time of insertion. Okay, now the set theory functions. Okay, we need public and set union, set other. Okay, I will comment later. Let's create the prototypes. And public set intersection, set other. Next public set difference, set other. And next public set, let's say complement, set other. And next we have to write the function public boolean is disjoint,
set other. Public boolean is proper subset set other. Okay guys, let's begin with the union function. So union function, take all the elements from set A and B and add them to the new set. That is the union of two sets. Okay, there is a possibility common elements, so no duplicate is managed by add function. So example, A is equal to, let's say 1, 2 and 5, and B is equal to 2, 4 and let's say 7. So the union will be A union B is equal to, we have 1 and 2 is in both, so we take it only once, and then 4 and then 5 and then 7. So this is sorted set, so maintain order. Other set and return a union of two sets. So how we will do that? Create new set. Set is equal to new set. Okay, next add all the elements from current set for int I0 is less than count I plus plus, and insert all the elements into new set. So set dot add data dot I, simple. Now run the same loop for the other set for int I0 I is less than other dot count and I plus plus. So set dot add other dot data dot I. Okay, and return set. Add all the elements from other set. Okay, intersection function to create an intersection of two sets. So intersection is the common elements. Okay, so example, set A is equal to 1, 2, 3, let's say 5, and set B is equal to and 2, 4, 5 and 7. So A intersection will be, we have 2 common and we have 5 common. That's it. So let's code it. Other set return intersection of two sets. This is a simple function. We create new set. Set is equal to new set, and loop for int I0 I is less than count I plus plus. Loop the current set. Okay, and check. Let's say int x is equal to data I. Okay, if other dot find x is not equal to -1. Remember this function? This function returns the index of element within the set. So if it returns -1, it means the element does not exist in other set. And if it is not equal to -1, it means the element exists within the other set. So if it exists in both sets, it is a common element. Find common elements and add to set.add x. Add it to the new set and return the new set. That's it. This is our intersection function. Now the difference of two sets. So we have one A set, let's say 1, 2, 3 and 5, and B set, let's say 2, and we have 5 and 7 and 9. Okay, A minus B is equal to the elements in A but not in B. So 1 is in A, not in B, so we take it. And 2 is common, we discard it. And 3 is in A but not in B, so we take it. And 5 is in both sets, so we do not take it. So similarly, B minus A is equal to 2 is in B and also in A, discard it. 5 in B and in A also, so we discard it. 7 and 9, two elements that are not in A, so it will return 7 and 9. This is how difference of two sets work. Other set and return difference of two sets. So similarly, we will create new set. Okay, loop for current set for int I0, I is less than count I plus plus. Okay, now if element does not exist in other set, take it. If other dot find data I is not equal to -1, so we add it to the set dot add data I. So we use it. So this loop will create a new set and add those elements that are not in set B but in set A, and we return the set. Now the complement function. Complement function works the same way difference works, but there is a fundamental difference. Difference is here we need two sets, and in case of complement we need a universal set. Universal set is the top level set that contains all the elements in subsets. Complement of a set. Okay, so this is an example. Union set, that is universal set. Let's say 1, 2, 3, 4, 5 and 6, and set A is equal to, let's say 1, 3 and 5, and set B is equal to 2 and 4 and 6. So complement of A is equal to all the elements that are in U but not in A. So 2, 4 and 6 are not in A. Similarly, B, complement of B is all the odd numbers 2, 3 and 5, because these odd numbers are not in B. This is how universal set, complement of a set works. All the elements from universal set that are not in the set are complement of that set. So set and return complement of the set. Okay, next, create set. So set is equal to new set. Now loop the current set, that is universal set. Loop the current set, that is universal set. For int I0, I is less than count I plus plus. So if other dot find data I is not is equal to -1, is equal to -1. Have to change this one because we need to take an element that does not exist in the other set. So add to the set data I. This will create the complement of the set. Return the set. Now disjoint function to determine a set is a disjoint. Two sets are disjoint. Disjoint means they have elements that are different. Not a single element is common. Okay, so A is equal to 1, 3 and 5 and B is equal to 2, 4 and 6. So they are disjoint because there is no common element. So we can also check by using intersection function. If we call intersection of these two sets, we will get an empty set. So we can do it in two ways. We just simply call the intersection set of intersection, and check the size of this. If the size is 0, we return true. Okay, so first method, set is equal to this dot intersection other. So if, let's say, return set dot is empty, that's it. We do not need anything else. Empty means disjoint, and otherwise not disjoint. Okay, now second method, let's comment it out. Okay, create set, method 2, set is equal to new set. Okay, loop current set for int I is 0, I is less than count, I plus plus. Okay, and check if other dot find data I is not equal to -1, means it exists in the other set. We simply return false. It means there is an element that is common in both the sets, and here return true, because if we reach here, it means the set does not exist. Sorry, the common element does not exist, and these are disjoint sets. Okay, now check to see if one set is the proper subset of current set. So how we establish proper subset? A proper subset is a set that has all the elements from another set. So if A is equal to, let's say, 1, 2, 3 and 4, 5 and 6, and B is equal to 1, 3 and let's say 5, and C is equal to 1, 2 and 3. So B is proper subset of A. Similarly, C is proper subset of A, because all the elements of B and C are elements of A, but B is not proper subset of C. Similarly, C is not proper subset of B, because they don't have same elements in each other. Okay, now other set, and return true if other set is proper subset of current set. Okay, let's code it. So create loop current set, int I 0, I less than count, I plus plus, and if now let's loop the other set, other dot count, because we need to check all the elements of other set should be in the current set. So if find other dot data I is not equal to -1, if it does not exist in the current set, so we return false. It means it is not a proper subset. and we reach here, return true. Other set is proper subset of current set. That is our list joint function. Oh, sorry, proper subset function. Now let's test the application. Okay. Create sets. Set u is equal to 1, 2, 3, 4, 5, 6. Oh, sorry. New set. Set A is equal to new set, and set B is equal to new set. Let's insert some function values. For int I is equal to 1, I less than equal to 6, I plus plus. Okay, so insert all the values to u dot add I. Okay, only odd values to a. If I percentage of 2 is not equal to 0, add it to the a dot add. Writing a loop is better than writing 12 statements. If I percentage of 2 is equal to 0, b dot add I. So this will become 2, 4 and 6, and this will become 1, 3 and 5, and this will have 1, 2, 3, 4, 5 and 6. This is our universal set. Okay, now let's print these values. So u dot print and a dot print and b dot print. Let's put their names also. Universal set A and set B. Okay, let's check if we are printing them correctly. Okay, so our sets are correctly created. 1, 2, 3, 4, 5, 6, 1, 3, 5 and 2, 4, 6. And check the order of their order is maintained. No matter how you insert into the set, the order will be maintained because it is a sorted set. Okay, now check the union. Okay, so set, let's say, is equal to a dot union b. So union of A and B. So it should be just like universal set. So set dot print. Let's check. Okay. Check this. Union of A and B. These are A and B values. 1, 3, 5 and 2, 4, 6. They are inserted into the new set, that is the union of both the sets. And see, the order is maintained. 1, 2, 3, 4, 5, 6. Now, intersection. Set is equal to A dot intersection B. Intersection of A and B should be a empty set. Okay, let's check. Okay, set is empty because there is no common element between these two. Now, set is equal to u dot intersect A. Intersection of u and A. So let's see what happens. Okay, it returns the common elements because U is a universal set. It contains all the elements of A. So it returns the common elements. Now the difference. Set is equal to U, let's say A dot difference B. difference of A and B, A minus B. So it should be empty set because, sorry, it should be the same set because all the elements of A are not part of B. Okay, it returned all the elements of A because there is no element common between A and B. Let's check with universal set. Okay, now universal set difference with A, U and A, U minus A. So it's the elements of A are 1, 2 and 1, 3 and 5, and it has all the elements. So it's supposed to return all the even elements. Okay, this is how it works. Universal set minus set A, 2, 4 and 6. Okay, next, complement. Okay, the complement of A is set B. The complement of B is set A. Let's check. Set is equal to U dot complement A. Let's copy this. Complement of A and complement of B. Let's print these. Okay guys, complement of A is set B, that is all the even numbers. Complement of B is equal to set A, that are all the odd numbers. That is how we build the sets. Because this is universal set, it contains 1, 2, 3, 4, 5, 6, all the number in sequence. Set A is only odd numbers. So complement of it is all the even numbers from the universal set. Same way, set B is 2, 4 and 6. The complement of B is all the odd numbers from the universal set. So complement of A returns set B and complement of B returns set A. Okay, now is proper subset. So let's copy this. Sorry, disjoint. Let's check disjoint sets. So if let's print S out is A and B are disjoint sets. So A dot is disjoint B. Okay, let's check these two sets with the universal set. So U and U with A and B. Okay, same way we check is proper set. If A is proper subset of B, no. Is B is proper subset of A, no. Now, if A is proper subset of U, yes. And let's check for the B also. Is B proper subset of U? Now let's change the calls. Okay, so A dot is proper subset of B. Is B dot is proper subset of A, and similarly U dot is A and B. Let's run these. Okay guys, so A, B are disjoint sets? True, because A contains all the even numbers, sorry, A contains all the odd numbers and B all the even numbers. Is U and A are disjoint? No, because U is the superset. Is U and B are the disjoint sets? No, because U is the superset and it contains all the elements from B and also A. Now, is A is proper subset of B? False. Is B is proper subset of A? False. Is A is proper subset of U? Yes. And similarly, B is the proper subset of U because all the elements of A and all the elements of B are the elements of U also because U is a superset. Thank you guys. This is all about implementation of sorted set using an array. Please practice and learn. And if you find difficulty implementing anything, practice again, try again. Only an effort can make you a successful person. So keep learning. And if you have not already subscribed to my channel, please subscribe and promote the content. If you need any help or you need any guidance, you can comment and I will reply. I will help you as long as I can. Thank you guys. Have a very good day and see you in the next video.